this episode couldn't be more timely because it just days ago, like maybe two days after this episode was recorded, we heard about the Hugging Face hack by OpenAI. On both ends of the spectrum, we're going to need some sandboxing and locking into this stuff down. This episode is about agent sandboxes, or just sandboxing anything. Hell, we for 30 years have had sandboxing technologies that we could label as a sandbox type thing with jails and Chroot and Docker and VMs. Like, these are all isolation technologies, namespaces, C groups, you name it. There's been a dozen or more attempts over the last 30 years. And now we are focused on agents and AI running amok on our local systems, but that's not enough. This is about sandboxing specifically with Nono. You can find it at nono.sh. It's by nolabs. And I had the founder, Luke Hinds, on the show where we went long on this one. And that's because there's a part of it where we talk about Nono, how it works. It's a command line that you can wrap any binary on Mac or Linux. On Windows, you would use WSL2 to run Nono. But it runs against the kernel primitives. So unlike many other ideas around isolation technology that use VMs or containers or both, this is focused on just using the native functionality of the kernel and giving you a profile for each thing you want to run in it. You can use it for everything. You use it for kube control. You can use it for GitHub command line. You can use it to run lots of other interesting things on your computer. It can even work with GUIs, potentially, as long as you can handle a sophisticated approach that a GUI requires in terms of file access and all that stuff. I'm very, very interested in sandboxing technology. Docker is one of the major players here. They have the sandbox or SBX command, which is a VM that runs Docker inside it that then runs the agent harness inside that. And Nono tries to take a much more direct approach by using the kernel primitives that are already there. And it's built by some really smart people that built SigStore. So there's all sorts of stuff that we dabble in. But this show, I think, will be essential learning for everyone using agent harnesses, which is essentially every developer and DevOps and platform engineer on the planet, because of one reason. As we get tasked to use cheaper models, the hallucinations will increase. And in fact, a cheaper model doesn't mean that hallucinations are more likely, but we are going to all probably at some point need to push the envelope for how cheap can we get it. In fact, I know teams that their egos reside on how little they spend on tokens by using cheaper and cheaper models, using haikus, using the GLMs and the Kimis. And these models may or may not be more likely to hallucinate. But as you push that envelope to how cheap you can get in a model, how old of a model can you get, or how cheaper of a smaller of a model can you get to run some of your workloads and some of your automations and CI, you're going to potentially deal with more hallucinations. So we've got it on both ends of the cheaper models are what we need, but that may mean more hallucinations, which may mean you need to care about locking your stuff down. Or the models are going to be so sophisticated that they might actually go a little more rogue in just the service of doing what you asked it to do. And if you leave them alone long enough, they may actually do something bad in search of doing the good thing. And so they're not necessarily nefarious. That's what happened with Hugging Face, was it was just trying to solve a test. It was trying to prove that it was intelligent. So it went crazy and wouldn't quit. And the sandboxing is an area where we've got lots of different options. And I like Nono for its simplicity and its ease of use in my day-to-day. And I'm now very interested in how can I use it in my CI and other places as well to sort of have a blanket approach. And we talk about a lot of those ideas in this podcast, so let's get to it. Welcome to the show. We've got Luke Hinds here, the co-founder and CEO of nolabs.
Thank you so much for having me. Enjoying this.
So just a real quick background on Luke here, because he's a humble guy. He's probably not going to tell you. He's kind of a big deal. He created SigStore, which one of my favorite security projects. SigStore is very popular. If you don't know SigStore, if you don't know, you don't know, go check it out. It's there to help secure your code, essentially, and give you some assurances. OpenSSF, which I'm also a very big fan of, and we talked about at least multiple times a year on this channel. You were a board member. I didn't know that. That's very cool. OpenSSF is a software security foundation? Is that?
Yeah, you got it.
Okay.
On the nail.
Yeah, and I love it's the rating system for how secure your supply chain is. It's like a checkoff list. I'm trying to remember what's that called?
Scorecards.
Scorecards.
Oh, SLSA.
Oh, SLSA.
Yeah, they're both scoring systems.
Yeah.
SLSA has levels. So yeah.
when I found out about salsa a couple years ago, I kind of got a little obsessed with it. Like I wanted all of my stuff to be the highest number. It's like points. And the nice thing is, I think it's what this show tries to do, and it's kind of challenging sometimes, is to get out of the esoteric, the theory, and get into the actual implementation. And where's our checkoff list, right? And so I try to get into those weeds because that's just how my brain thinks. And salsa is that. Like, it is this wonderful standard, hasn't changed a ton, but it allows you this list of hardening down all the different parts a little bit of your supply chain, whether that's the building or the provenance information that you need to have, your artifacts you're building, like Docker images, and sort of steps through all the different parts you need to think about. And you kind of just rate yourself. It's not something where you go and get someone else's opinion, but you go through. But somewhere in here, you dig into the individual parts of it. Okay, we've got the build track, the source track. I like that these are broken out now. And as you dig down into it, you eventually come to a list of steps that I learned a lot from years ago when it first came out, like when it was in pre 1.0 or something. And so it's cool to have you here because I've never actually had someone from the OpenSSF on the show, even though that's not what we're here to talk. We're here to talk about sandboxes. So tell me, how did you get interested in sandboxes? Like, where's the origin story for you in helping to lock down binaries, essentially? Have you been adding text-to-speech in your apps? One of my late-night projects this year was creating a personal podcast feed so I could listen to the changelog of my favorite open source projects while I do my chores. I needed a text-to-speech API to do that. I also heard from a colleague this week who built an app for his kids to turn their ebooks into audiobooks, and he's using the Speechify AI developer platform to do that text-to-speech. Speechify AI is a developer platform for real-time text-to-speech, and they make their own voice models. Their Simba 3.2 model ranked #1 on the Artificial Analysis Benchmark for conversational voice quality. They've got a free plan, streaming and REST APIs, TypeScript and Python SDKs, and if you want to get fancy, you can use their SSML metadata support to add emotion into the speech output. Whether you're shipping a weekend project or production voice agents at work, you can start free at speechify.ai. The link is in the show notes. Thanks so much to Speechify AI for sponsoring this episode.
I'd historically worked with malware, especially malicious packages, obviously be part of the software supply chain focus. And I needed a way to very quickly isolate potentially bad things from running on my machine. Okay, so you can use, there's many technologies you can use here, Dockers, VMs, but I wanted something very quick. Okay, so I had this little tool that I used where you could very quickly isolate a process. So what do I mean by process? A process is a running application on a Unix type operating system. So you run PS and you see a list of all these processes. And this was something that I had for a while. Never really had any plans to go far with it at all. And what happened was OpenClaw. So the OpenClaw agent was released and it was carnage. The security situation was pretty bleak. A lot of people were being compromised. They'd never really had this level of exposure to a technology this powerful before. And so I thought, I'm going to just put my little project out. I'm not going to promote it much. I'm going to just put it out there to help people. It was kind of an altruistic cause. That's what it was. And this thing blew up. So I went to the top of GitHub trending and suddenly loads of people converged and started making issues and saying, can it do this? And can it do that? And then I realized I've got something popular. It's really resonating with folks. And I think what really helped Nono propel was you'll see it's a very small CLI. It's very fast. There's no infrastructure needed, no hypervisors, runtimes, and it's able to wrap anything. You can wrap an agent in there. You could wrap curl. You could wrap ls. You could wrap wget. Basically wraps processes. It does a lot more than that now, but it was very unique for a sandbox, really, because a sandbox is normally, there's quite a bit of apparatus just built around them. And this was something quite new. And it seemed to really resonate with folks.
It was my first sandboxing experience, other than like all of the other cheroot and jails and like all the other, we could argue that what kind of sandboxing those are. You could debate that whether Docker is itself a sandboxing tool. But it's one of those things where we have been trying to manage and mitigate the blast radius of a single binary as an ecosystem for 30 plus years. We've been wanting to run ever since we were able to run more than one process, I guess, ever since the 60s. I have a little mainframe blood in me, so I'm not quite as old as the 60s, but we were using 60s mainframes in the 90s in the Navy. So I get to go back way back to the green screen terminals in my career. We've had limited success. And I think one of the biggest challenges is like UI UX, right? Like if it's too painful, we don't use it. And in fact, my confession on the show today will be like right now, because I don't have any active consulting clients at this moment. I'm just making pure content. So I don't have anyone that I need to like sweat it. I don't need to sweat every command on my machine. So the only sandboxing I use is either Nono or sometimes the built-in like Claude Code stuff, but I actually prefer Nono simply because the other tools that I've used, either I don't understand them or, like you said, there's a little more pomp and circumstance to using them. There's a little more formality. And I just don't, since I don't need that, Nono just works. And I love the templating system, so I don't have to be an expert in every, if you think about like the processes, the networking, the file system access, like all these different parts, none of us really know when we use an app every day what it needs access to. Like I didn't realize until I started using Nono how much Claude Code tries to creep into my system. Tried to access my browser extensions, trying to access different directories. And Nono immediately helped me understand that. And I think like the only other tools I've seen that do that are tools that are more diagnostic in nature. Patrick Wardle, he makes like some Mac utilities for security and firewalling and file watching and stuff like that. And then the famous sysinternals, wininternals on the Windows side from Mark Rosanovich, those have been around for 30 years. And those were really all about tracking file. You could see every file it touched, did it write, did it read, and you could sort of, but it wasn't meant as like a firewalling system. So to have this kind of utility feels almost like a superpower, because if I'm nervous about something, I can just throw Nono in front of it and it's gonna not do nefarious things. So tell us a little bit about like the elevator pitch for someone today they're using agents, they're using AI, they're still at the shell, they're a shell fan. And what would Nono do for them?
Absolutely. So I'm not particularly great at elevator pitches, but I'm going to do my best. I'm notorious
this is
for
an
spinning
engineering
over.
podcast, so don't.
Yeah. I kind of probably more of an escalator pitcher. You see what I mean? But no, with Nono, you can get going incredibly quickly. Okay, so you pick whatever coding agent you want. We have a profile for that. And it's as simple as Nono pull on the name of a profile. That will pull everything down for you securely. And then you do Nono run and you pass in the name of the coding agent and you're off. Nono's in the background. You need never do anything more. Okay, that's all you need. So within just a few seconds, you can be sandboxed and just get on with your work. Now, if you want to go deeper, you absolutely can. There's a lot to Nono under the hood, but it allows everybody. It's a big church. People can come in, get going quickly, and then the experts, they can find their way and go deeper and deeper.
Well, I guess the good point there is that, like, even I was early days, I feel like, for Nono. Actually, thanks to my friends at ChainGuard, because they were bragging about you, telling me that I should check it out. But my onboarding experience was like read one page of documentation and then copy and paste the command, and I'm back in Claude Code, or back in. At the time, I actually think I was trying to use OpenCode, and I think you all were just developing the OpenCode profile, and I think I was commenting on an issue or two about making sure that worked, because at the time I was kind of obsessed about OpenCode. I've kind of moved over to the dark side with the walled garden of Claude Code, but it works in both, and I also tinker with Pi, and I've played with it there. That was my first use case, but seeing all your demos of showing how I can just wrap any other commands inside that, and how I can control networking or secrets with this tool has really made me realize I basically need to spend more time with it, because I have like those 1.0 or those V0.1 limitations in my mind, and I'm now like, oh, this can do more than I realized. I need to start leaning into the egress, because at least for me, That's the first thing I'm willing to let an agent do is I'm like, yeah. Like as long as you're isolated in my system somewhere, I'm just going to let you access anything on the internet you want to get to. And I know that I probably should have a more nuanced understanding of like, where does my agent actually normally go, and where should I care, or should I limit it in that case? Is there like an audit mode where I can see things, like I can see the tracking record, but I don't have to see it doesn't actually block it. It just lets me know what it was trying to access when it accesses it.
Yeah, so we have two approaches there. One is when you exit the session, anything that is attempted to be accessed and is being denied, it will give you the option to add that to your profile. And it will also guide you around if something is particularly sensitive and you want to add it, then it'll ask you just to double confirm, like secrets and so forth. The other system that we have is that there's an audit of absolutely everything the agent does, every domain it calls, the path, the environment variables, the binary, its fingerprint, the SHA-256, the tools that it calls, the specific tools, the flags, everything is audited. And we have this model, essentially, where everything in the agent space, the sandbox, is untrusted. But there's an adjacent trusted side, which we call the supervisor. And this is the one that captures all of the audit. And it's the one that feeds in we call phantom tokens. So they're not real credentials. It's not your real GitHub token. It's a random string, which the agent gets. And we essentially treat the agent kind of like a prisoner. Okay. So if you think about, you go to like a penitentiary, you can't just keep somebody locked in a room. You need to give them a bit of authority. They need to go make their phone call, go to the canteen, walk around the yard. So we allow agents to do that, but we limit where they can go and we limit what they can have, and we still keep a good eye on them. Whereas I think a lot of sandboxes, it's been more around lock them in the room and never let them out. But really, for agents to be good and effective and to do all these amazing things, you need to give them a bit of authority. You need to trust them. You need to allow them to have access to things that are a little bit powerful. And we're able to carve out very, very safe paths around what that agent can actually do. So we dog food Nono a lot. So things like the AWS CLI, we very much lock it down around what environment variables it can have, the URLs that it can call. We will limit it to just the get method. So it can't post, it can't change things. It can only do read-only operations. We do this with kubectl a lot. I know you're a Kubernetes guy. So we prevent like replicas from being a large number and clusters being deleted and namespaces. And this way we know the agent can just go for it. It can explore, it can debug clusters, but we stop it from doing the dangerous stuff. And we do this care of what we call tool sandboxing. So with Nono, you get a main sandbox that each time the agent wants to call a tool, we spawn a micro sandbox. It's a very small, ephemeral, short-lived sandbox where it gets its own unique policy. And if it's allowed a specific secret, it's allowed it, but the rest of the sandbox doesn't. So that way your AWS CLI can access the credentials, but curl doing a post and a file read can't, because that's data exfiltration. So I think this is where we're quite different to a lot of the other sandboxes. Yeah.
Yeah, I saw a couple of the demos on your YouTube yesterday. I was checking out the channel. I was really interested in how, I use the GitHub command line tool constantly. It's either me or the agent using it constantly. In fact, I built this GitHub security analyzer tool that I built. It gets your token from the GitHub command line tool to talk to the API, because that just is the easier way to do it. Let's code on my side. And seeing the demo of how the profile will limit the put requests to particular URLs of GitHub as a way the way I looked at it was that this is a way for me to use my existing login and not have to go create a custom pat. Because that's what I've been doing in some cases, where I go and I make this. I've been making a lot of pats this year, like fine-grained personal access tokens, so that I can have these nuanced profiles and realize. And it's a tedious. Then I got to store that pat somewhere. I got to put that one out into the thing I want. And this method of no, you have one pat, you have all this access, but you could actually limit the agent in a different way because it's all just HTTP, right? I like that approach, and I'm excited to see that sort of take on, to be more prevalent, because it feels like a more scalable model than 1,000 pats for agents for every profile and because if I have 3 clients as a consultant, I'm on GitHub, I'm always very nervous about that because some people, they work for companies, they create a separate user account because that bifurcation of permissions in the pat can be really nerve-wracking when I realize my one pat has access to a dozen organizations and my login on my local GitHub has way more authority than it should have probably for a single login on a single machine. And your profile methodology around the URLs and whether it's Git versus post and all that it makes sense to me. I like it. So I've not used it a lot yet, but I watched the demos and thought, I got to learn this.
Absolutely. And this is all discovered through our own pain, really. Using agents and seeing things go astray. We realized that we wanted to really limit what the agent can do. So we do L7 filtering, the path, the method, and so forth. But we also do the arguments, because what will happen is an agent will try to use the GH CLI command, and it will try to use arguments, and then we will block it. We'll say no. And then it will try to pipe raw GraphQL through, and we'll pick that up and we'll say no. And then it will try to wrap it in a shell. It'll do SH pipe, and we pick that up and we go no. And then you just see them give up. And I won't name them, but certain agents will be very, very persistent. And then eventually they go, I'm done. You got no running. I give up, essentially. And this allows us to really kind of look after ourselves, really, because we don't want agents posting to our organization settings. We don't really want them posting. Quite a lot. These things will just create issues when you didn't want them to. And so we really sort of are able to, somebody described it as zero trust for the terminal, which was kind of quite a good way of putting it.
Yeah, if you had that marketing arm, that's probably what your website would say now.
Yeah, absolutely.
Yeah, because that sounds like a very buzzworthy zero trust CLI. And I don't disagree. I mean, it sounds like a good thing, like something I want. I mean, I love, every time I hear zero trust, I think, ooh, that's what the safe kids do. I use YOLO mode. So if we back up a minute and talk about like the unique design of this app, tell me how it uses the native kernel, because this thing is all running on my Mac directly. Like it's not creating some sort of VM or a container or some other abstraction. It's just right there on my machine. And then it also works on Linux, which is a completely different kernel. I don't know if it works on Windows yet. I think I saw the website where it said WSL2 was the way to do it. But tell me a little bit about how that works.
So we use 2 native sandboxing technologies. On Apple, we use one called Seatbelt, which has been around for quite a while. If you look at Apple's documentation, they will say it's deprecated, but it isn't, because it's used by some really huge projects. Chrome very much relies on it. So it's not going anywhere. It's just not as well documented. And that allows us to do file sandboxing and basic network sandboxing. We also then have Landlock, which is in Linux. And Linux Landlock is what we call an LSM, the Linux Security Module. So it sits alongside SE Linux and various sort of well-known security primitives in the kernel. And this again allows you to do this file-specific, network-specific sandboxing. Now, there are several approaches within Linux. You'll hear namespaces, C groups, kind of full-on micro VMs like Firecracker and gvisor. We actually went with Landlock because it suited us very well for this tool-specific, very fast sandboxing. But also, we don't require any elevation privileges. You don't need to use root or sudo. We run in user space. And this is really important for Nono because this means Nono can practically run everywhere. You can run Nono in our Docker image. We mentioned ChainGuard. We use one of the stripped down ChainGuard Rust images, which we run Nono in. You can run Nono on many different types of compute. It'll practically run anywhere, okay? And it's very similar to I think the trajectory that Docker had. I'm a huge fan of Docker, okay? And how Docker went from this localized tool that developers loved to this large-scale orchestrated system for workloads. Now, what typically happens with Nono, somebody will start off in an individual way, like you are. Okay, they'll start to create their own profile. They'll maybe check it into GitHub. It becomes their thing that they create over time. And then they'll find team members and they'll start to share these things and they'll start to set up more and more profiles for all the different environments they're in. And then eventually it'll get to the point where they'll go, well, we could just lift and shift this into a Docker file. So the entry point could be nono run profile agent. And then like, right, okay, we're on Kubernetes now. And so it's got this very seamless ability to run anywhere. And that's where it's very good for sort of walking the journey with you. You can start off with never used it before, quickly isolate my coding agent and perhaps share a home folder and my development folder. So you start off there, you go on the journey, you learn more and more, you go down the rabbit hole, and then you start working in a team capacity. And then you start looking at, right, okay, we want to run this in production. So how do we do that? And that's where Nono's experienced a good amount of adoption, essentially, because it's got that kind of seamless deployability.
I saw that you had a blog post, because one of my questions was going to be like, where else is this used? Because it seems like such a core utility that if it could run on the Mac kernel, it can run on a Linux kernel. Where in the cloud is it running? And I saw that you had this post, the GitHub Action supply chain attacks are here, so stop giving CI your release token. We just had our previous episode that released on the podcast was about the new GitHub agentic workflows, which does a lot of this hardening in an automated way where they're trying to ingress, like read-only file system, everything in a container that's got the inputs and outputs are filtered. Like there's all these different steps. Tell me about like, what are you seeing in CI? Like what are the advantages of using this in CI?
So we run Nono in GitHub Actions. We realized it was very effective. So we can do native sandboxing, care of the fact that GitHub Actions, the underlying host system is Linux. And we then released a project called RunSeal, where it's an action that you can easily consume and use. And then there's a simple YAML structure where you can set what domains you want to allow that workflow to connect to. And you can do credential injection. So the execution environment where the action runs, it cannot have a real token. It gets a spoof token, a phantom token, we call them. And you can limit which domains it can call to. So a lot of these sort of fork attacks that happen in GitHub Actions, typically they look to exfiltrate a secret GitHub token, and they will look to exfiltrate to a specific domain. And we can lock all of that down. So we can lock down an action to just being able to talk to api.github.com. All of the secrets are useless outside of that operating context. They're only useful within that short session. And we can also do a lot of supply chain stuff. So we do a lot of SIG store stuff in there as well. So we do a lot to sign skill files. You can do a GitHub action provenance, like Salsa, of your skill files. And then when the agent tries to access those skill files to read them in the sandbox, we do a verification that the files as they exist in GitHub have not changed at the moment the syscall comes in and the agent tries to access them. Because this is how prompt injections happen.
Yeah.
And again, that's one of the things we do that we're not very well suited to telling folks this. We have full end-to-end supply chain security in Nono as well, which is something that a few people don't know.
Yeah. I can see how I like the idea of signing my skills and then verifying them, because that's always the part that everybody skips, is the verification at runtime. It's not always obvious. It's sometimes hard when you're pulling artifacts. Like Kubernetes images, like for a decade, I feel like I've been talking about and helping people understand the signing and verification nature of container images. And I've loved that we have objects now that we can sign. I can actually build my apps and have SIG store to sign them. But the ability to guarantee that skill is indeed my skill it's probably one of those things where, like so many of the security tools, there's very few percentage of engineers, let's just say 10 or 20%, probably less, that are really paying attention to that stuff. But I tend to, on this podcast, I tend to kind of try to shout all this stuff from the rooftop of, like, it's not that hard. It actually isn't. And you can always start somewhere. Like, it doesn't have to be end to end. Like, if you just had one GitHub action that you tried Nono with, and you actually bothered signing a skill or something like that, or you actually bothered limiting to the API egress, like, that's a start. And you don't have to boil the ocean with these tools and think that every single nook and cranny has to be solved. Of course, agents, I think, are going to make a lot of this easier. I think I'm finding that one of my favorite use cases for agents is not, obviously, we all started with like writing code in YAML. Mostly for me, it was YAML. Dockerfile is YAML, TOML. And I find that implementing sort of like org-wide changes as a DevOps person or as a platform engineer has always been problematic, because you end up having 100 repos that you want to make some sort of change to, or you've got 50 Kubernetes YAML repos spread out everywhere, and you want to make some functional change in there. And then you have to write your own scripts that would go through and automate each one. And I find that agents make the implementations of a lot of these things so much easier, because the repetitive nature of a lot of the work that I feel like we do in the operations space can be alleviated with this. So I'm looking at this tool and I'm thinking, well, that's a change to my workflows, and that's me tracking some URLs and extra things, not that much work. But once I've done it once, I kind of can just ask the agent, please give me PRs for all of them. We're going to review them together, and then you're going to implement the PRs. Where else outside of CI? Like, okay, so you talked about Kubernetes production. We started with the idea of local harnesses, which is, I think, where probably a lot of us are getting started. Then we realized it's for more than just our harnesses. Then I realized, I can put this in a CI, and I can help harden, like the fact that GitHub Actions doesn't even have egress filtering firewalls today. I know it's coming. They're saying it's coming this year, but like, we don't have it yet. And we haven't had it for the 8 years or 6 years that we've had GitHub Actions. So people can start doing that, and they can start limiting the secrets access into their apps, which we also can't very easily do with GitHub Actions without using environments and other fancy features. And so they start to get it into more of their CI, and then they realize they might be able to harden some workloads in production, particularly agents that we're all building with agent SDKs. Is that an area that you explained that earlier? But I guess that's a very common dev thing to do, is we're all trying to build these agents, whether it's for our own automation or for a line of business app. And we put these things in containers and we think we're done. We think we're okay. What does this do in a container? Like, what's the argument for why I need this in my containers in Kubernetes? Is it because I could more easily set a policy to lock down to non-root and all that in there?
Yeah, so you're touching on a great point here to really kind of differentiate Nono from containers and micro VMs. And it's not one is better than the other. They really complement each other well. Okay, so one of the things that you're picking up with Nono, it's what we call a capability-based model. It's fine-grained. Okay, so you're able to be very specific around individual files that can be accessed, perhaps read or write or execute. Very fine-grained URL filtering, the secrets injection, the skill attestations. Now, with a Docker image, if you were to try to do that, that's going to be a lot of volume mounts that you're going to be constantly. Operation is going to be very expensive to do that, because you're going to have to maintain all of that. Okay. And so Nono was built more for this new world of this very fine-grained agent in its operating context, protecting the spaces there, essentially. And Nono is not as good as containers and micro VMs at complete isolation. It's Berlin. It's protected. I mean, you get kernel exploits, of course, but generally it's a very good, solid, monolithic layer of isolation. You know where you stand. It's a safety belt. Nono is more of like I said, it's a very fine-grained, very customizable thing. And so we often say to folks, when you run Nono in an operational production type scenario, run it on top of a micro VM, run it on top of in a container. Okay. And then you've got the best of both worlds then, because I see micro VMs containers, where they're really strong, is the threat model is really about an agent lets off, it executes something malicious, something bad, untrusted code is executed, it's contained. Okay. Now, our threat model is partially to do with that, but we're actually looking at agents that have good intent. I know an LLM doesn't have intentions as such, but we've all seen this thing where you did, Claude, what, you've deleted the data? Oh gosh, I'm rightfully sorry. I should never do that again. And
You're absolutely right.
They can hurt you while they're trying to do their job. Do you see what I mean? And that's the whole new threat model that I think you need something like Nono for, which is how do we let these things have a bit of power, give them a bit of responsibility, like we spoke about earlier, give the kids the car keys, they're going off to university, you start to give them a bit more responsibility. But you want to keep it safe. Do you see what I mean? You want to have those guardrails there still. So it's not around completely contained, lock you in a box. So you can't do anything. And then it's very difficult for you to do things. And what we all love about agents is magic. It's incredible what they can do. I'm not particularly good with OpenTofu and YAML, and I could learn it, but there's only so many things you could do in a day. Whereas an agent can go off and do that. It can debug, why is this not deploying? It can solve things really quickly, but there's a lot of risk in that because of if it goes off course, it can really cause a lot of problems. And so I think that's the key differentiator with us really is we're fixing a different threat that we now have in our midst.
Like the way these tools work is often very much based on their origin story. And for example, like Docker, whether it's Docker or Kubernetes, it's all running containerd 99% of the time anyway. So in containerd, there is probably a way to look at system logs to see that it tried to access a kernel primitive that Docker didn't allow, right? But that is not a user-facing default thing that you're seeing in Sesh because the tool was designed in a world where we thought the code was good. We weren't terribly worried about the good code trying to do weird things with the file system that weren't necessarily trying to exploit. It's just trying to get a job done. It just wants to be helpful. It's just Yeah. If I had another analogy for you besides the car key thing, it would be like I could see Docker as being described as the butcher knife, where it's a blunt instrument, and you're like the paring knife, where I'm doing that fine detailed work on
precisely.
And in fact, do you see with these templates? And I haven't checked. Maybe you already have this. Do you see where, like, I'm imagining a workflow for me, and my advice to people eventually, especially part of this DevOps guild that I've created, is we're really looking at patterns and practices, trying to figure out where we can operate safely. Like, what's the responsible way to use agents as an adult, right? As someone who's been in this craft for decades, as most of the people that are in the guild are a little bit of gray. They've got some experiences and some battle wounds. And everybody's on a different end of the spectrum concerned around security and safeguards and how many PATs do I have on my machine that it can get access to in Claude, right? Or in Codex. So there's a lot of utilities that have a lot of logins on my machine across a wide spectrum of tools that can do a crazy amount of damage. And I never have to worry about that until AI, because I was the only one typing in we all worried about the front gate, right? My password's strong. You can't get into my code on my machine. And my hard drive's encrypted. I'm doing all the right things. I got my firewall on, but I'm now running this very helpful thing that's a little too eager sometimes. And so we're trying to figure out, like, what does the day-to-day look like of someone who's running an agent locally, running a harness, they're operating infrastructure, they're maybe writing some code and doing some PRs, but they've got this blast radius where they technically could take down the entire AWS cluster with a single command. And that's on their machine, logged in by, it's saved in a config file. Is it something where, like, you would have multiple profiles and I would bring up my agent for troubleshooting? I got something going on in the cluster. I got an idea of where I need to look, but I need to point the agent at it. So I spin up Nono with my open code or my Claude code or whatever, and I'm using a very specific profile that maybe I've named like Kubernetes read-only or GitHub read-only. And I allow it to access certain things, certain URLs, and it does that troubleshooting. And then I realize, this is a policy change that happened in Kubernetes that I need to quickly undo. And I'm not a GitOps. I'm not going to do it the GitOps PR way. I'm just going to go right to kube control, but I want the agent to do it. So now I've got to flip my nono profile over to a writable profile, but maybe I only want it for this one cluster because I don't want it to have every Kubernetes token. And so now I've switched profiles to one that's maybe specific to a Kubernetes specific cluster. It's got a specific key. It's maybe given me a limit. I've given it limited write access in that profile. Is that something where like there's a list of profiles the team manages together? Is that a thing you see? I'm just trying to imagine the workflow of like the daily efforts of a platform engineer.
So with nono profiles, they're JSON, okay, and they are composable. So you can inherit. So there's a Claude code profile, which is available. Now, if you wanted to extend that and add your own specific grants and denies, you can just do extends and it will pull that profile and it will inherit it as a parent.
Oh, nice.
And then you create your profile as a child. So you've got this kind of composability. So this sort of works very well in an enterprise setting. Got a little bit more work to do, but you could have like your kind of corporate thou shall not pass. Absolutely. Never, never, never. And then you can allow different teams to be perhaps a little bit looser or access certain environments, test environments and so forth. Probably would have been quite useful for the stuff that happened a couple of days ago with Hugging Face and OpenAI. But we've got this, it's composable policy. Okay. Now, the interesting point, you really raised on a really good point, which is what if I want to swap profiles mid-session? Okay. Now, that's very difficult to do with a sandbox because it kind of breaks the fundamentals of what a sandbox is. They're meant to be, you start them, they're immutable,
right,
and then they exit. Okay. But we have come up with a really good solution where we're actually able to expand grants during the sandbox's life cycle. Okay. And we do this with a lot of kind of trickery pokery with Unix processes, inter-process communication. It's a lot of kernel stuff again, where we're able to, if an agent needs a file that it doesn't have access to, we feed something called a file descriptor, which is, it doesn't actually get the file, but it gets the file access care of this supervisor. And the supervisor, it's a little bit like the jailer, where we spoke about penitentiary. So if you want something, you've got to go guard and bang on the door, essentially.
Right.
And so we are able to do that now. And some people have been looking at using this approval backend to plug into a policy system, like, for example, OPA. So some people have existing policy engines. They're like, we really like how you've done policy in Nono, but we've already got a policy engine. So that's where these approval backends come in effectively. And you can also do things like, I've seen folks, they wrote a Slack approval system. So when an agent gets stuck, there's a webhook and it posts to Slack, and then they can approve it in Slack. Now, obviously, some people are going to be more security stringent than others. Okay. They may not like the idea of Slack being an approval system for an agent, but this system is, you can build around it effectively. You can build around this interface.
That is really cool.
And so a very long way of saying, you can actually expand that runtime now. So
that is cool. Is that a Linux unique feature? Are you able to do that on Mac as well, or is?
Yeah. So with Linux, you definitely get a lot more bang for your buck because what we can do with the kernel, but it does actually work on Apple with the tool execution, these sort of tool sandboxing. Okay?
Oh, right.
So so for example, like the GitHub CLI, if it wants access to something that it doesn't have, because it's not in the local policy, the JSON, there is an order. So if not local, then fall back to the approval system, and then it can ask the approval system. So I've seen people rig that into the Apple fingerprint password reader. We've done a lot of interesting work where we originally started doing a lot of stuff around machine learning and training models. So we're looking to do some work there around to make it easier for folks to understand what to approve. Because there's this thing called approval fatigue, where it's just kind of, you just kind of hitting a tab or whatever it is.
You got like the little bird thing on your desk that just shakes and it's just,
precisely.
It's just hitting the inner key.
Yeah, very much. Yeah. So we're all engineers
yeah.
trying to use these agents. So we tend to experience these problems ourselves. They're pains for us and we seek to solve them. And luckily that works for others as well,
Yeah. The best products are always the ones that the builders are using themselves to get their work done. So
Yeah, absolutely.
do you think there will be a day where harnesses, like when you talk about these approvals in session, is this an extension of, I'm trying to think if I've experienced this. I only remember experiencing it when I exited the Claude Code or whatever. Is this something that you think would be like an extension into the harness that would give it abilities for approvals through Nono? Is that a thing that's happening? Or
very much, yeah. Absolutely, yeah. So we've got a video that demonstrates this with kubectl, and it's running on an Apple Mac Silicon machine.
Mm-hmm.
And there is aspects of the operations it needs to perform that aren't granted in the policy. So we run a simple Python web server that's able to pick that up. And then you can approve things like it wants to scale the amount of pods. We don't allow that. That's considered a kind of a write operation, but we allow it to go to the approval system. And so it's not something that comes batched in with Nono at the moment, but it's a programmatic interface that's there to integrate with, essentially, yeah. And so, I mean, us, obviously, we love open source, but I have a company, a dog, a family to look after. So eventually we're building a product, essentially, but we'll always keep the open source powerful and free. That's the way I've always done things. But that's where we will start to really introduce how this works at a large scale, effectively. How do we handle thousands of engineers and agents that need these very sort of multi-dimensional threat assessments around approving and denying and what should be allowed. And
you've already kind of hinted at this, but I'm guessing that a lot of this is like, it almost feels a little bit like a cat and mouse with an agent where you block. And then the more that when Fable comes out, and it tends to be a little bit more tenacious, it tends to be a little more eager as a model. And so it tries different or new innovative approaches to getting around a sandbox. And so do you feel like that it's a little bit of that, of like, aren't you cheeky for figuring like, oh, you did that in Python, I didn't think about that, or you did some weird HTML escape that somehow got I'm sure there's some good war stories you got.
Absolutely. So what we do is we test where we lock an agent up and then we pipe lots of tasks in. Okay. And some of them are tasks that interpreted a certain way could cause trouble. Okay. And then we make a cup of coffee, sit back and just watch it go. And it's like Homer Simpson, dole.
Yeah.
And then eventually he's so satisfied, it just gives up. He said, no, you need to change your no policy, man. I can't do this.
It's like you won against a friendly Terminator. You're like, okay, you admit defeat. I still can control the AI.
It's funny. Sometimes I'm like, seriously, you're going to use Perl? Like, is that how desperate you're getting, Because they're incredibly crafty.
Mine lately has started to get confused sometimes with web searching and web crawling or web fetching tools, and it will resort to bash calling curl sometimes for websites.
Yeah.
And I have to stop it and okay, you're going crazy. This is not how we're going to search the internet, by guessing website names and curling them.
And you just reminded me of something else there. Of course, we can do this with MCP as well. So we can kind of, MCP is a set of tools, okay? And so we can kind of do a safe path around MCP execution, especially the stdio stuff, which is all localized.
Right. Is that something where it's like it would be like a command line option, or it's just a part of your profile, like you have files and other things, and there'll be a section for MCP?
So, I mean, like if it's stdio, typically people will do MPX and they'll pass in the name of the MCP.
Mm-hmm.
It's a kind of, I guess it's like a JavaScript, compiled JavaScript. And you then say what that is allowed. You can give it a phantom token rather than it getting a real credential. You can say what URLs it can access. And because that's another tool that's incredibly powerful, But with, what is it they say? With power comes great responsibility. And these things don't have responsibility. So that's where no comes in. Yeah.
There's a couple of good taglines probably that the future marketing team could work out with that.
I mean, I'm not here to promote my company, but that's why we called nolabs. Because we thought, well, somebody's got to be looking at how to say no. Because we're all saying yes. And just yes, more, and just giving more and more power to agents. And we thought somebody's got to look at the nuances of no. When do you say no? So teach your agents when to say no.
Yeah, I like it. It gives you a very specific purpose, which my company name is extremely vague. So it can do anything. So I have no purpose.
I was just going to say, and we don't have a model. So our interests are in saying no.
Right.
If you've got a model, sometimes I've got to be careful here, but the more that model can roam, the more products it can find. Okay, right. So no is no with us.
Yeah, the incentives aren't necessarily aligned with model companies.
Exactly.
Sure. So what's next for No? Like, what are you excited about for the rest of the year? Can you give us a little preview taste?
So do you know it's not very exciting, but it's essential. Stability. Okay, so we are now really focused on. We've got an incredibly powerful payload. So we're trying to just slow the roll a little bit when new features come in and really improve the documentation, give people lots of examples, really make the user experience as seamless and as least brittle as possible, investigate more ways of surfacing and solving profile denials and really just starting to dial in the quality. Because a lot of people are starting to use this as their day-to-day tool. They're running this in teams. Some people are running production agents. We have people using No in production already. One of the things with No, we've been looking at coding agents, but this could quite easily be Pydantic AI, LangChain, ADK. You can run anything in there, essentially. So it could be No run Python main.py. And you'll immediately get all that Nono has to offer through your agent that you've developed, essentially. And so, we're really looking at improving the quality around things. And of course, as No Labs, we're looking to build on top of this effectively. Because again, to use Docker, I'm just so fond of Docker. And they had this model of kind of the chef's kiss of developer experience locally, but you needed a Kubernetes to orchestrate and scale this. And that's where we're doing a lot of research at the moment. How do we make No this policy operate across a diverse, large fleet of agents effectively, to be able to track everything and resolve all of these approvals and exactly.
Centralized logging and policy generation. I can see that I can envision the management portal coming soon. It feels like the right approach. I mean, it feels like one of those things where it catches on in a dev team. I've got some DevSec engineers and some security engineers in our agentic DevOps guild, and they're all very much looking at not just the security of agents, but the security of skills. They got to pay more attention to No Labs to see if there's anything coming down the pike for them to administrate and manage centrally. And then the idea of like signing skills, we're kind of like in our skills moment with the learning and that we're doing in the team, where we're trying to figure out centralized management. None of this stuff is really figured out in the industry. We've got lots of ideas and we've got lots of walled garden proprietary solutions, but a lot of what we do in open source is like, well, we kind of wait for them to figure out the market and then we figure out if there's an opportunity for open source. And this feels like that moment where we've got the registries for skills, but like the idea of signing it and then validating it on runtime, that feels like it should be built in. And so it feels like there's maybe an opportunity for someone to make an open source project that could kind of be like the cloud native, we got the CNCF and the Linux Foundation, but if something there for skills as well as for sandboxes, because it feels like we're going to need a little more formality in the standards as the harnesses all sort of bifurcate.
I 100% agree.
Yeah. Well, I definitely got to use this more because I think it's kind of like agents themselves, right? I feel like No is one of those things where you get a taste for it and you get comfortable with it and it starts to become something that you're using more and more. And then pretty soon, my vision of like all these different profiles I'm extending, that I have ones for certain use cases on my infrastructure. And I start to get more comfortable because I think, like a lot of us, I have been YOLOing it. My Claude command line is an alias to Claude dangerously skip permissions. And we have been lucky to rely on these super high-end state-of-the-art models that mostly don't, at least this year. Like last year was crazy. Last year it was trying to, delete my hard drive. And I think at one point I was trying to get it to build a Swift UI app, and it last year with like a Claude, like it was like a Sonnet 3.5 or something. It was determined that my Xcode installation was broken, and it was going to delete the entire directory off of the system profile. Because it was like, oh no, I can't. The build was failing, but it wasn't the fault of his code or its code. It was the fault of my build tools. So it was trying to delete all the build tools. And I luckily caught it last second. I think some of us have gotten a little more comfortable with the models behaving better. But what I'm now seeing, and this is maybe, I don't know if this is a trend overall, but as people start to reduce costs, because like Opus is crazy expensive, so they start to try to see how cheap they can get the models. Like they sort of, we use skills testing and evals to try to see how cheap we can get this token budget. But in doing so, you inevitably, there's like this gray fine area in the middle where you get just cheap enough, and then it starts to hallucinate, which means now at that point, I need no. And so what I'm finding in our guild is that as people mature and they realize not everything needs Claude models, like you can use GLMs, you can use some Kimis now, you can use some of these cheaper open weight models. But now, as you know, on the rabbit hole of how cheap can I get it, and I have a couple of teams where they're now the inverse of this token maxing thing, where they're bragging about how little their spend is. Like it's sort of a sign of engineering expertise that I've been able to do all this with a super cheap model. But I think that they're going to need more guardrails. And so this is almost like a specialized use case of, you could argue in a marketing campaign, use Minimax at cents on the token comparatively to at 5% the cost of Sonnet, but you're going to need some harness protection. You're going to need to keep it on its rails. Yeah.
Yeah. And as you rightly put, we're completely agnostic. You can run any agent. And whereas other sort of enterprise sandboxes that are coupled to the lab, they can all be split apart effectively. So you can, as the next new cool Pi open code, whatever comes out,
whatever's next,
you use your same profile, maybe adjust it a little bit.
All right, last question, because we're running long, and I apologize for that.
I've so enjoyed this.
What about GUI apps? Like, where's the rough edges on this? Because at first I started using it, and then I realized I maybe couldn't run Mac apps in it, and I wasn't really sure if that would work. And like some people are using the GUI harnesses.
Yeah, absolutely. So you can use Nono to isolate in a sandbox the GUI. The real aspect to consider is if you've got something like an Electron app, like Button is one quite often, spray a lot of file access all over the place. Okay. So you would be able to eventually write a profile for it, but they tend to be, they tend to kind of a little bit feely grabby. But we are able to do that. I've seen people get the Claude GUI. I've seen people get VS Code running. I don't know. Okay. But then it starts to get complex when you've got all these different extensions and I've heard of people trying to get Nono to isolate extensions as well, which is interesting. But basically, if there's an entry point, at some point the rubber hits the road, you're going to call an executionable, a script, and it's going to execute a process. And that's where Nono sits. So there's a level of complexity that's involved. If you had something like a video editing app, probably run Nono in that, but it's going to have a very wide blast around what it needs.
Yeah. Your Electron description, especially like with VS Code extensions. I mean, we just recently had the big VS Code extension hack. So it made everybody wake up and realize that extensions are still code running on your system, and we all knew we shouldn't download random ones, but also like even the reputable ones can also be attacked. And that's why I really like Go. I love static binaries now. Like it's my whole thing. I don't want a distributed code base that's to compile at runtime. Like I preach about this a little bit at conferences about like, we've got 40 years of programming languages we're all using, and they were all created at different eras of technology. And this is a little bit of a rabbit hole, but like we were optimizing for the problem of the time. And now like the problem at the time is I need 5 different Python versions. That's like why Docker exists. One of the reasons it exists is because we couldn't use the same system library for every app, and we needed separate installs, but the systems don't really account for that. So then we have to come up with abstractions. And here we are today, and I'm like all in on whether it's Rust or Go. Like I want that single binary experience, but I know that with a lot of these Electron apps, it's dozens of node binaries. It's like with Chrome, you've got a process for every tab. You've got extension processes in every tab. Like you've got a ton of stuff there. So I can only imagine how big these profiles. So it seems like it's going to require a certain level of determination to get it working. But it's cool that it's possible. I was assuming that it was just maybe something on Mac that wasn't going to be possible because of the way the notarization, and because there's already a security system built into Macs that we as users see as pop-ups that are very user friendly and weirdly still tell you nothing about exactly what you're asking permission for. And I've always assumed that model, whatever that locking system lock model was a little bit different than shell tools.
Yeah, we do stuff around within profiles. You can provide access to things like IO-Kit and kind of Apple fundamentals like that. We had to get in the ability to allow GPUs, which meant there was a lot of sort of, I didn't actually work on that, so I can't speak with any authority there, but we have to kind of, there's these sort of Apple primitives that we have to allow effectively. So you can do that as well here. And Nono's developed in Rust. So I love Go as well. Wrote most of SIG store in Go. And we went for Rust. We're really strict around the use of unsafe and unwrap, and we do lots of security checks on the code and look for race conditions. And so we landed on Rust because I don't want to argue one's more secure than the other, but it's one where we knew where we stood, really.
Yeah, it feels right. It feels right for the job. And I love that. I mean, most people that are, I don't know. I know a lot of engineers that are fans of both. Like they use both. And
absolutely. I adore.
Yeah.
It was just it's a work of art. Absolutely,
yeah. Docker was my gateway. Docker and Kubernetes were my gateway to go to. And now it's like to me, it's like the replacement for Python as the sysadmin language. But hey, it's just a preference. Like I know people that spend their whole day in Python as a system engineer or a platform engineer. And thanks to Luke for being an awesome security engineer, making open source hits. Let's hope this, I mean, it already sounds like this is a hit, but let's hope it blows through the stratosphere and stays in the top GitHub repos, because I as someone who likes to, I'm always like security team adjacent, never really a dedicated security engineer, but always that DevOps guy sitting next to them going, hey, let's work, let's hold hands. So I love when security tools are fun and easy to use and like make me feel like an elite hacker. And that's kind of what this makes me feel like, is like I'm paying attention to primitives, but I'm also reining in, and any security engineer standing over my shoulder would not judge me harshly for my dangerously bypass permissions defaults.
Absolutely, yeah. That's by design. Security tools, it's hard to get adoption because you're normally kind of scolding people, hitting them on the head, telling them they can't do things.
Yeah, telling them what's wrong.
So, I mean, SIG store was one where we managed to and make it almost seamless. The developers liked it because it's rare that developers like a security tool. And no, it's the same, really. It's out of the way if you want it to be.
Yeah. And I'm sure there's going to be a dozen more use cases for it. So we'll have to have you on again.
Absolutely.
To talk about all the new use cases for Nono, because I got a feeling that as we all start to venture out into the ether of new models, other harnesses, building Agent SDK model harnesses, like we're all going to learn these lessons, I think, a little bit the hard way and look for solutions. Hopefully Nono is the one they pick. So
absolutely.
Glad to have you on, Luke. Everybody can get started over at nono.sh. There's a really quick guide. You can install it with Brew and all the typical utility ways to install. And of course, because they're security focused, they like the Mac is notarized, like all the good stuff there. So if you want to know more about that, like the future of where Nono is going, maybe head over to nolabs. That's nolabs.ai, where they've got a couple other things they're playing around with. It looks like you've got some other ideas. So I'm excited to see what comes out of the team. And where else? I guess they can see you on all the socials, and you have a YouTube channel for Nono.
channel. Yeah. If anybody runs into any issues, we've got a Discord that's pretty popular. It's a lot of no notes, as we call them in there.
No knots.
And you'll be able to find that on the, I think, nono.sh and the GitHub repo. It's got a link to the Discord. And Nono doesn't really have any other social channels apart from that.
Keep it simple. All right. Thanks so much for joining me, Luke.
Pleasure to be here. Everyone. Thank you so much.
Yeah.
Bye-bye.
Ciao. Thanks for joining us, and I'll see you in the next episode.